All right, so first thing that we're going to look at is average rate of change. That is just a fancy way of saying slope. You have 2 points, you just find the slope between them. I left a lot of space here because we're going to draw a picture, but real quick, just to review slope from Algebra 1, let's make up a problem really quick. Can you guys just shout out some smallish numbers to me and off to the side here? All right, I heard 5, what else? Let me make that one negative. And then I need another point. Let's do -1, and I heard somebody say 3. All right, just write down those 2 points. In order to find the slope, you need 2 points. Does anyone remember the formula? If not, obviously I'm going to. Good, you're going to subtract the y values, subtract the x values. You can call them y2 and y1 and all of that, but subtract the y values, put a fraction bar, subtract the x values. All right, so it is going to be, and do you remember what letter stands for slope? M. All right, M. It's going to be 3 minus -2 over, and then you're going to subtract the x values, -1 minus 5. Again, I know this was back from like Algebra 1, but sort of memories of this vaguely. Slope, okay. So what would we have in the numerator? Good, 5, and then down here, -6, and that's your slope. So you just subtract the y values, subtract the x values. All right, let me draw a picture here. We're going to put this in like a general format. Just draw yourself a swoop. I think that's the easiest. Just draw yourself a graph doing something. And we're going to find a point on that graph. So the input would be x, and the output would be f of x. Is everyone coming with me on that thought journey? If you input an x, you get back an f of x. So if you want to write that point off to the side, that point would be x, comma, f of x. This is going to look weird with the notation, but the concept itself is not difficult. You input an x, you get back an f of x. All right, now we're going to put another point on here, which means we've traveled a distance down the axis. I don't know why they picked H to be the letter of the alphabet that stands for, but you travel a distance H. So what would this be right here? If this is X, and then you went a distance of H, this would be X plus H. It's where you start. Oh, what did you say? Oh, well, we are going to plug it into the function. So what would the output be? If this is X plus H, the output would be f of x plus h. Whatever you input, you get back f of whatever that is. And when you connect these, we're going to find the slope of that line, and that is your average rate of change. Do you know the real world quizzes that I give you, those little data quizzes? Do you know the one that's like you went on a road trip and you averaged 40 miles an hour or whatever? That's like what this is. It's an average rate of change. You're connecting the 2 points doing the slope. All right, so the other point is x plus h, comma, f of x plus h. So those are the 2 points that we have. Question? Okay. And we're going to do the exact same thing that we did right here, except with this. Okay, so realize it looks a little funny. It's the exact same thing we did with these values, except right here. So you're going to subtract the y values. You're going to subtract these. So it'll be f of x plus h minus f of x. We just subtracted those. It's just this one minus this one over, and then we're going to subtract these two. So it would be x plus h minus x. I realize it looks like the alphabet threw up on your paper, but the concept isn't that difficult. Are you with me on these 2 points? We just subtracted them. All right, this is called a difference quotient. Difference means subtraction. Quotient means fraction. We subtracted and it's a fraction. What can we simplify? There's one thing that's going to cancel out here. Yeah, these x's in the denominator, x minus x, those are going to go away. And here's your difference quotient. F of x plus h minus f of x all over h. You do have to know that, okay? So maybe put some stars around there. But you have until the test to memorize it, which isn't until we come back from break, so there's plenty of time. Also, once you do a few problems, you're gonna almost like accidentally memorize it, because once you use it a few times, it's just gonna, it makes sense. It's also not that big of a formula, okay? Some of my students were showing me yesterday all the stuff they have to memorize for chemistry, and I was like, this is not anything near that. So you can memorize it, I believe in you, okay? So what your directions are gonna say is find the difference quotient for the following functions. All right, the first thing you're gonna do is plug in x plus h. You're gonna do f of x plus h. So if we plug x plus h into this function, that will give you 5x plus h minus 1. You just plug in x plus h. Are we all still together? Plug that in. And then it's minus f of x. So that's minus the function. Just make sure that you give it a hug. You need to subtract the whole function. It's minus f of x. And then the whole thing is over h. Once you get it set up, now it's just a bunch of like distributing. You're just going to simplify this down. Distribute the 5. What does that give you? 5x plus 5h minus 1. And then what do we need to do here? Yeah, flip the signs. You're distributing a negative, so they're just going to both be negated. It would be minus 5x plus 1. Again, that's all over h. Now, if you're paying attention, you should realize some stuff that's going to happen there. If you do this correctly, almost everything's going to cancel out. What is going to go away here? All right, the 5x's, good. And I heard somebody say it, the 1s. So you end up with 5h over 5. Oh, I'm sorry, over h. I apologize. Thank you. Copy error. 5h over h. And then what's going to cancel? The h's, and you just get 5. That should make sense, because what are we finding? Slope, and this is a line with a slope of 5. So if it's linear, you actually don't have to do any work. You can just state the answer. Do you see how this is y equals mx plus b? You don't have to do any of this work for this one. What is the slope of this line? I want you to know what you're doing, but I hope you know at this point I am not about busy work. If there's a shorter way to do it, that's what we're going to do, right? Yeah, it's slope. Because at that point, you're telling me you understand what a difference quotient is, you understand that it means slope, and you understand that the slope is -2. So it feels like you didn't show a lot there, but it actually does show a lot of understanding, if that makes sense, like in your brain. All right, these ones aren't going to be linear, so you are going to have to actually do the work. I'm going to write the difference quotient on the board again so that you don't have to keep flipping your paper back and forth. First step, you're going to plug in x plus h. So it'll be, oh, good. It'll be x plus h squared, which means that we want to write it twice, and then -2. So plug x plus h into the function. Then it is minus the whole function. So just make sure you put parentheses around that. You're going to minus the whole thing. If you're feeling comfortable just negating the terms and just doing that, like, you can go ahead and do that. And then it's all over h. All right, listen up, kiddos. You're going to do x plus h squared a lot with these. I'm going to work it out once, and after that, I'm going to expect you to know it, okay? Because you just, it's repetitive. You're going to do it over and over again, right? X times x, then x squared. The outsides will give you xh. The insides will give you xh. So together, it is 2xh. And then h times h is h squared. So I'm going to write that up here. That's what you get when you square x plus h, because you're going to do that a bunch. Okay, -2, and then distribute the negative sign all over h. Now, again, if you have done your job correctly, you guys seem really unfocused back there. Are you with me? This is the only thing we're doing today. So I'm going to give you like the bulk of the block to yourself. So I need you to pay attention. If you've done your job correctly, a lot of stuff is going to cancel out. What do you see that's going to go away? All right, x squareds are gone. 2's are gone. That leaves you with 2xh plus h squared over h. And then what else can you do there? Because there's one more step. Yeah, divide by the h. One of the h's is going to cancel, and that will just leave you with 2x plus h as your final answer. We're just going to practice it a couple more times, right? Again, I wrote it up there for you. The first step, you're going to plug in x plus h. Oh, look, the first thing is that we're going to do x plus h squared. That's going to be this. So it'll be x squared plus 2xh plus h squared plus 4 times x plus h. You have to plug the x plus h in everywhere that there's a variable. So there were 2 places to plug that in. And then what? Minus the whole function, and then it's all over h. I usually get asked at this point, Miss Cole, do we have to draw the over h for every single thing? I won't take off if you don't. However, I will take off if you forget to cancel out the h at the end. And I think if you don't write it, you're probably going to forget that. It's not that big of a deal. Just write over h. All right, now we're going to do some distributing. So we're going to distribute this 4, that'll be plus 4x plus 4h, and then distribute the negative. And then again, if you have done your job correctly, a lot of stuff will cancel out. These are almost like self-checking problems, because if you don't get stuff to cancel, you'll be like, oh, whoops, I had a mistake somewhere. Or I dropped a negative. Like, you'll catch it because the stuff has to go away. All right, what's going to go away for this one? All right, x squareds are gone. 4x's are gone. And here's what you have left. 2xh plus h squared plus 4h all over h. And the last step is you're going to cancel out an h. So just go through and divide an h out of each of these. You're just dividing by h. So what would the final answer be? 2x plus h plus 4. Perfect. We're just going to try one more. All right, again, the first step, you're going to plug x plus h into the function everywhere that there's a variable. So it's going to be 3, and then it would be x plus h squared, which is this. You might just like put that in the margin of the paper and then you'll have it there. Or like, I'll just leave it up here, right? Plus 6 times x plus h minus 1. Again, you have to plug the x plus h in everywhere that there's a variable. And then minus the function. And then it's all over h. And like I said, we've only done what? This is the 5th problem. Do you feel like you've already almost like accidentally memorized this? Like, it's not that big of a deal. Like, it looks a little scary, but after you do a few, it's not so bad. All right, then do your distributing. Distribute the 3. You're going to have 3x squared plus what? It's 6xh, or are you all ahead of me? You're like done with the problem. All right, plus 3h squared. Distribute the 6. That'll be 6x plus 6h minus 1, and then distribute the negative. And all of those terms are just going to be negated all over h. And then we're looking for stuff that's going to cancel out. So what is going to go away here? This is the fun part, I think. Like, you just get to like slash it all out. 3x squared. What else? 6x and the 1s. Yeah, I like that. That's satisfying to me. Like, oh, look at it's all going away. And that's also like, hey, I did the problem right, you know? Because if you don't get that to cancel out, you're like, oh, whoops, I had a mistake. All right, so let's see what's left. 6xh plus 3h squared plus 6h all over h. And then your last step is to cancel out an h. So it would be 6x plus 3h plus 6. I'm just going to end with this. People get good at doing these problems, and then you become a little correct answer machine, just turning out correct answers and have no idea what it is that you're actually doing. What are we finding? Slope. Okay.